This video will be for FST, just a quick review for students prior to their Chapter 7 test. This is the review list that was posted to Moodle, and so I'm just going to talk through each of the pieces. The only one I'm not going to talk about here is long division, because there was a whole lesson on that, lesson 7.3, so students can simply review the video of 7.3 to review long division. But the rest of the topics will be reviewed in this video. For the factor theorem, notice that it's only 1 point, and the basic structure of that is going to be that you're given a function which is some kind of polynomial, and then they're going to say that when you plug a number into that polynomial that you get the number 0. So that means then that x minus or x plus the opposite of that number is going to be a factor of that polynomial. So for instance, if you had a polynomial called f of x, and they said that f of 2 was equal to 0, then x minus 2 is going to be a factor of whatever that polynomial would be. So that's what the factor theorem is all about. For graphing a polynomial and then identifying the intercepts, zeros, and writing the factors and finding the polynomial, we talked about this one in class, but I'll just mention it again here. That you'll have to use your graphing calculator to graph a given polynomial. You'll graph it and you'll identify where the zeros occur. You can do that by using the menu command and then analyze graph and then choose 0, and you'll put vertical lines around each of the zeros. You'll have to do that command three or more times potentially to find all the zeros. Once you have the zeros, you'll list them out, and then you'll write the factors. So similar to the factor theorem, if you know that negative 2 is a 0, x plus 2 is going to be a factor. If the other zeros are 1 and 3, then you'll do x minus 1 and x minus 3 as the other factors. Then you would simply use your algebra skills to multiply two of those together, and then take your answer and multiply it by the third, or whatever else you have left, to get your polynomial. If you don't get your polynomial back, the one that you originally graphed, then you know that you did something wrong. The rest of the test is going to be baby calc. And so we're going to talk about factoring last. Long division, you should check out the 7.3 video. Multiplying complex numbers together, the two complex numbers are going to be given to you, and then you simply do FOIL. So I've already done FOIL here. A reminder that I squared is equal to negative 1. So in this case, negative 6 times negative 1 is going to be a positive 6. That gets added to the 8, so that makes 14. The negative 4i and the positive 12i in the middle here are going to make an 8i. You always want to write your answer in complex number form, so you put the real part first and the imaginary part second. When you do intervals on a graph, you're just going to have to indicate where it's increasing or decreasing, or where it's positive or negative. So for example, if I were using the graph that's pictured here, I would say that the graph is increasing from negative infinity up to a. If that value of a wasn't there, I could have just labeled it myself and called it anything I wanted. So negative infinity up to a, the graph is increasing. If I was talking about where it's decreasing, I'd say from a to b it's decreasing. And again, if b wasn't there, I could have put that point in for myself just to be able to talk about the graph in a way that everybody could understand. I'd also say that it's increasing from b to infinity. If I was talking about it being positive, I'd want to include some other letters here, and I'd talk about maybe C, D, and E here. I'd talk about it being positive between C and D, and then from E to infinity it's above the x-axis, so those would be positive intervals. When you're doing polynomial vocab, they may ask you to identify the leading coefficient or the degree or any of the other topics that were listed in lesson 7.1. So for example, if this were the polynomial you were given, you would say that the leading coefficient is the number 2. Right now it looks like the leading coefficient should be the number 4. But you always want to identify these vocabulary words after you've put the polynomial in standard form. If you put this polynomial in standard form, then this term would actually be at the beginning. The highest exponent term needs to be in front. So if I put 2x to the 6th on the left where it belongs, then 2 would indeed be the leading coefficient. It's the smallest coefficient, but if I put it where it belongs, it would be the one that's in front, which is what leading means. The degree would be the highest exponent, so in this case that would be a 6. The last thing we're going to talk about in the video is factoring, so I have a bunch of practice problems we're going to look at. So one of the things you'll have to do is what I call reverse FOIL. So if you're working with a trinomial with a leading coefficient of 1, you'll simply do the diamond, and you'll look for factors of -24 that add up to -10. And so that's just a matter of you thinking that through. Usually you find your factors of the number that you're multiplying by first, and then you see which pair adds up to the number that you're looking for. So -6 and -4 are the ones that would work there. And I apologize, that should be a plus. Sorry about that. It should be +24. Another type of factoring that you're going to have to do is cubic, factoring the difference or the sum of cubics. To set those up, there is a straightforward template that we looked at in, I believe, lesson 7.7. You take the cube root of the first term, so the number and the letter, you have to find what would multiply by itself 3 times to make that. So in this case, 3 times 3 times 3 makes the 27, and x times x times x makes the x cubed. 1 is an easy one, it's its own factor. If there is a minus there, then we need a minus at the front of our binomial. Now we take these two pieces and we build the rest of the answer. At the beginning of the rest of my polynomial, I take whatever I had at the beginning here and I square it. So 3 times 3 and x times x, that makes 9x squared. In the middle, I multiply these two together regardless of the sign, because I'm going to have positive positive in my second part of my answer. Then at the end, I just take the second piece and I square it. You should always look for if there's further factoring that can be done. And so in this case, you'd want to look for factors of 9x. If you wanted to do the diamond and the grid, I think you'll find here that it doesn't work. And so if you were looking for complex factors, you'd have to go ahead and do the quadratic formula. The next example is chunking, and I can tell right away because if I cut it in half, there's going to be a common factor for these two that's different from the common factor for those two. So when I pull out the 4x, which is common to the beginning two terms, I'm left with 3x plus 1. If I pull out a 5y, which is the common factor for the last two terms, I'm still left with 3x plus 1. Because that factor that's left over is the same in both cases, I pull out a 3x plus 1, and what I'm left with is a 5y and a 4x. So those become a term together. And so that's called factoring by chunking. The next one is called factoring by substitution. I'm going to pull out, and I apologize that this step is not shown right now, I'm going to pull out the piece that's repeated in my polynomial. X squared minus 4 is repeated twice, so I'm going to pull that out and I'm going to see what's left. The thing that I pulled out is x squared minus 4, and I replaced it with the letter u. So the problem when I rewrite it without that is going to be u squared minus 3u minus 10. So now I'm going to try to factor that using the diamond. So factors of -10 that add up to -3 are -5 and 2. Now that I'm done factoring there, I'm going to go ahead and put my substitution piece back in. So I replace u with what it was, x squared minus 4 in both cases. I simplify those and I get x squared minus 9 and x squared minus 2. X squared minus 9 is a difference of squares, so that becomes x plus and minus 3. The difference of squares on this one, because I don't know the square root of 2, I'm just going to leave it as square root of 2. I don't need any i's here because they're both minuses. If either of these were a plus, I would include an I in my answer. The last one uses reverse distributive. I pull out whatever's in common to all the terms, and when I do that, I'm left with 9x squared plus 3x minus 20. I want to double check the trinomial that's left and see if I can factor that further. Now you can use the diamond and the grid here, or the X box, and to review the steps for that, you would take a times c on the top and b on the bottom and find factors of -180 that add up to 3. So you know the factors need to be 3 apart. Then you fill in the original ax squared, which would be 9x squared in the center. You fill in the original c value, which is -20 in the lower corner. Grab the two pieces from your diamond, including an x with both of those, and then you look for GCFs vertically and horizontally. Once you've done that, 3x plus 5 is one of your factors, 3x minus 4 is your other factor, and don't forget you had pulled out a GCF of 7x squared. Now personally I find that this, because the number on top is so large, is somewhat difficult, and so I probably would have done this by guess and check method instead. Pretty much the only factors that I use when I think about 9x squared are 3 and 3. And a typical factoring system that people would use for 20 would be the numbers 4 and 5. So I'd probably do a guess and check there and would avoid kind of the headache of having to do the X box. But know that the X box will work. It's just going to take you a little bit more time to do.